Alright, so I wanted to show you my antenna power. This is a piece of flashing. I think it's about 20, maybe 22 feet long, 12 inches wide. And then I just took some of this coaxial cable and screwed it onto here. And it goes down into my shop. Alright, and then this is my ground, my earth ground. It's a piece of conduit. I hammered that thing in the ground. Maybe 2.5 feet. So that's the ground wire. And then that's where my antenna goes in. Right in there. Alright, we'll go inside and I'll show you what I got. Alright, so there's my antenna. Hooks on there. And there's my ground. And I've got it going into this 10,000 microfarad. 10,063 volt. So right now I've got this red wire. It's shorting out the capacitor. And what I'll do is unshort. Actually, what I'll do is show you just strictly the voltage right off of the antenna. So unhooking this, and here is the voltage on the antenna and ground. It's peculiar too because I'm getting DC voltage. I've messed around with these antennas before and you always end up picking up AC voltage from your house. It's always 60 hertz. But here, we'll switch this one to AC. And I'm getting very, very little AC. There's the... It's strange too, because it acts like a battery, as like a galvanic battery. But it's hard for me to understand that because I have an aluminum, it's either aluminum or galvanized antenna, and my ground rod is steel, or it's galvanized, galvanized conduit. So that's just the antenna. Now I'm gonna unhook this capacitor so it's not shorted out anymore, and we'll hook it to the capacitor. And it's the negative's the ground and my antenna is the positive. There's no diodes, no nothing. And that's how fast it can charge 10,000 microfarad capacitor. I mean, this is not very fast, but it is definitely charging it. And then I'm going to unhook the capacitor just to look at the antenna voltage. It's strange how it rebounds slowly, as if it's a capacitor itself. It doesn't just like shoot up to the voltage or nothing, it has to build up to it. Which makes me think it's like a battery or like a capacitor. Alright, now I'm going to hook it up again. And that's charging the cap. Alright, I'm going to pause it and I'll see how full it can get. Alright, we're back. It's slowing way down. I wanted to show you something else that's pretty interesting. So I've got this 6-volt battery here going into the circuit. It's just a pull circuit with the MOSFET and a diode, one of those, I believe it's a fast switching diode, ultra fast possibly. And so it's strange. You can take, it's really strange actually. I have 2 coils wrapped on here. A green one, and there's a little red one. The red one's being pulsed. The green one, you can see, goes to nowhere on that side of the coil. And then on the other side, it goes to the diode. Now, and you can see it comes out to nothing because I'm not charging any batteries right now. It does the same thing, charging a battery or not charging. And it's, so I plugged in right here before the diode. So basically it's just one wire connected to that coil. The other wire is not connected at all. And originally I thought it was something to do with my power supply. So I hooked it up to the battery to see if I can eliminate that. And I got it running through these 2 diodes here. It's like a bridge rectifier, but this side's not connected on the bridge rectifier. Where the AC line would come in, it's not connected there. Now here is the capacitor voltage. I just shorted it out, so it's kind of very, very slowly rebounding. You guys see it's just about stabled out here. Okay, and here's that other capacitor. It is still charging through my air antenna. Now, you can see that these wires come from that battery to here, and whenever I turn this thing on, it can charge these capacitors with one wire. There is no other wire connected. Now, I'll hook this up. And here's the capacitor voltage. Now you know this is a 6-volt battery. So if it was leakage from the battery, it would never get over 6 volts. So it's not coming from the battery as far as battery leakage. Now there's no ground wire hooked up to this at all. Because the one side is just naked. I just got one wire feeding it. And this other coil, it's not even connected to anything. 10 volts. I'm going to touch the other side of that coil and see what happens. Seems to go up a little faster. So now we're at 12 volts. And this is just the antenna capacitor. It's still charging. Now, I'm going to undo the ground from this capacitor. And I'm going to hook it up to this side and we'll see if it charges any faster. We're at 14. Just climbing pretty quick. Okay, it's connected. And I'm going to disconnect it. And I'm going to reconnect. There's no ground. And here is ground. No ground. That's strange to me because I only got one wire going to this capacitor. I'm not fully sure how is it completing the circuit when nothing is connected on the other side of it. We're at 17. Now it does do a lot faster job if I do connect it to the power supply, so I'll show you that. Okay, we're 18.5. Now I'm gonna hook it up to my power supply. And you can see here's the power supply. Okay, now I'm gonna unhook it from the power supply and I'm gonna hook it back to my 6-volt battery here. Okay, we're connected. Alright, thanks for watching. Just curious to know how come this capacitor can charge with one wire and the other coil is just floating here. I mean, I can have it not touching anything and it can still charge it. It's not touching anything. Very strange. And that's back on the battery, so and you know what, real quick, I'm gonna I'll discharge this thing real fast just to show you. Okay, we're at 22.6.7. Okay, there's totally short. I know capacitors will rebound a little bit on their own, but that sucker's charging. It's charging up to a pretty good voltage. Alright, thanks for watching.